Let us discuss and revise the previous class what we have studied about the blockchain, cryptocurrency, hash function. So let us revise and then move to the next part. So as we know what is blockchain technology, we have discussed that is blockchain is a decentralized and distributed digital ledger. Ledger is nothing but it is a digital record of all the transaction made and during the network of computer, or we can say as it is a digital record of all the transaction on a network of computers. So blockchain is a decentralized and distributed digital ledger technology that securely record transaction across multiple computers in such a way that the registered transaction cannot be altered, that is retroactively without the consent of the network. So, and then we have studied through cryptocurrencies. A cryptocurrency is a digital currency which is an alternative form of payment created using encryption algorithm. The use of encryption technologies means that that is cryptocurrencies functions both a currency and a that is virtual accounting system. Then we have discussed about hash function also. Hash function, as we know, it's a cryptography are extremely valuable and are found in a particular every information security application. A hash function transform one numerical input value into another compressed numerical value. That is only the major goal of hash function. That is hash function transform one numerical input value into another compressed numerical value. It is also a process that turns plain text data of any size into a unique ciphertext of a predetermined length. Okay, that length will be predetermined. Then what is cryptographic hash function? See, we called as in a short form was CHF. Okay, that is nothing but cryptographic hash function. It is a equation that is widely used to verify the validity of data. Okay, major goal of cryptographic hash function is nothing but widely to use for verification of or validity of data. It has many applications, particularly in information security. For example, user authentication is a major part where we are using this cryptographic hash function. A CHF translate data of various length of the message into a fixed size numerical string of hash or the hash. A cryptographic hash function is a single directional verb, making it extremely difficult to reverse to recreate the information used to make it. Secondly, then we are going to see about how this cryptographic hash function works. See, follow these three steps to make sure about the hash function of cryptographic, how it is working. A hash function accepts data of a fixed length. The data block size varies between algorithm. First point, the hash function accepts data of a fixed length. The data block size varies between the data size varies between algorithm. If the block are too small, padding may be used to fill the space. Okay, if there is a block size is too small, so the padding process may be used to fill the space to cover the lefted area. However, regardless of the kind of hashing used, the output or hash value always have the same set of length. Remember, this is a key point. The output or the hash value always have the same set of length. Then third point, when we talk about hash function working, the hash function is then applied as many times as the number of data blocks. Okay, then how does a cryptographic hash function do? What does a cryptographic hash function do? Major point of cryptographic hash function, the hash function in cryptographic takes a plain text input and produce a hashed value output of a particular size that cannot be reversed. Okay, make a note of this. The hash function is in a cryptographic takes a plain text input and produce the hash value output of a particular size that cannot be reversed. However, from the higher level, the high level viewpoint, they do more. Okay, so what are the things we have when we work with this cryptographic hash function? Secure against unauthorized alteration. It assists you in a even minor changes to a message that will result in a generation of a whole new hash value. Okay, then we have what is the plus point, or what is the advantage we have when we talk about cryptographic hash function? Protect password and operate at various speed. Okay, many websites allow you to save your password so that you don't have to remember them each time you log in. However, keeping plain text password on a site public facing service, that is server, is risky since it oppose or expose the information to the thieves. Website commonly use hash password to create hash value, which then let make a like more they which they then store it. Now we are going to talk for the new topic of this class, that is application of cryptographic hash function. So we are going to talk about the application. So we have the following application, that is for message authentication. Then we have that is 1 minute, let me make it enlarge so it will be more clear. Okay, so now let us talk about method that's message, and the authentication is one of the application of this cryptographic hash function. Message authentication is a system or service that verify the integrity of communication. Always remember, you can make a keynotes, remember it before, like whenever you want to use these key points, you can go ahead with the key points. It ensure data is received previously as transmitted with no modification, insertion or deletion. A hash function is used for message authentication, and the value is sometimes referred to as a message digest. Message authentication often involves employing a message authentication code, that is MAC, or that is MAC method, that is message authentication code. MAC are widely used between two parties that share a secret key from authentication purpose. A MAC function uses a secret key and a data block to generate a hash value that identifies the protected communication. Then we have one more advantage, that is called as data integrity check. Hash functions are most commonly used to create checksum for data files. This program offers the user with ensure that the data is correct. The integrity checks all allow the user to detect a modification to the original file. It does not ensure uniqueness. It does not ensure the uniqueness. Instead of altering file data, the attacker can update the entire file computer that compute a new hash and deliver it to the recipient. So it is most important when we talk about the data integrity check. We have to always make sure with these applications, with this cryptographic hash function, the data will be more secure. Then we have digital signature. A digital signature application is comparable to message authentication. Digital signature operates similarly to the MAC, that is message authentication code. Digital signature encrypt message hash value using a user private key. So the digital signature may be verified by anybody who knows the user's public key. Okay, so let us talk, these are the some of the advantages, or we can say as an application used by the cryptographic hash function. Now we are going to talk about hash tree and data structure. So a hash tree is also known as Markov tree. Always remember the other name of hash tree is Markov tree. It is a tree in which each leaf node is labeled with the hash value of a data block, and each non-leaf node is labeled with the hash value of its child node labels. So two things, like when we talk about do you remember about trees structure, how they have one will be the parent and remaining will be the child? So similarly we follows here also a Markov tree as a parent, we can say as node, parent leaf node and a parent node. So that way the leaf node also work with the parent node. So here, what is cryptographic hash? A cryptographic hash is a function that outputs a fixed size digit for a variable length input. See, remember this cryptographic has a fixed size digits for a variable length input. A hash function is an important cryptographic primitive and extensively used in blockchain. For example, SHA 256 is a hash function in which for any variable bit length input, the output is always going to be a 256 bit hash. Okay, you can see this diagram, dog, flower and dog play with the flower, hash functions that has been generated and with the key generated, which will be the fixed size of 256 bit hash. So we'll see the next slide. Let me zoom out. Okay, now I hope it is clear now. Okay, yeah. See, from the above picture which we have seen, it is clear that even the slightest change in the alphabet in the input sentence can that is a big challenge. Okay, when we talk about this small changes in the context, it become a big challenge if it works in between. So the hash often, therefore the hash can be used to verify the integrity. So comes here, the picture comes for the integrity, as we have already discussed. The data integrity, verification integrity is most important application of cryptographic hash function. So here also we are defining that only, verifying integrity. Consider there is a fixed text file with input data. Pass the contents of the text file into a hash function and then store the hash in the phone. A hacker manages to open the text file and change the data. Now when you open the file again, you can compute the hash again and compare this hash value or hash with the other stored previously on the phone. It will be clearly evident that two hash do not match and hence the file has been tampered with. So with the help of this hash value function, you can able to identify if the hash function does not match together, that it is directly declared that the message has been tampered in the middle during the transmission. So what is hash pointer? Now we will discuss about hash pointer. A regular pointer stored the memory, as we know memory address of the data. With this pointer, the data can be accessed easily. On the other hand, the hash pointer is a pointer to where the data is stored, and with the pointer the cryptographic hash of the data is also stored. So a hash pointer points to the data and also allow us to verify the data. The hash pointer can be used to build all kinds of data structures such as blockchain and Markov tree. So see here, data you have in the diagram and you have a hash pointer with that pointer to the data and hash of the data. Two things you are working with the hash pointer. Then let us talk about blockchain structure. So blockchain structure is a combination of two hash based data structures. See, first one is linked list and another one is Markov tree. So what is linked list? As we have studied in a data structure, that is, this is a structure of a blockchain itself, which is a linked list of hash pointer. A regular linked list consists of nodes. Each node has two parts, that is data and pointer. The pointer point to the next node. In the blockchain, simply replace the regular pointer with a hash pointer. Markov tree. A Markov tree is a binary tree formed by hash pointer and named after its creator, that is Ralph Markov. So see in the diagram we have h of function, h of function, h of function, where they have interconnected. There is a transaction data and they on the next label, that is, one section has covered with the keywords and next section is covered with the transaction data details. Okay, next to slide. Let me zoom out. Okay. Oh, yeah. Blockchain. Here we block structure. We are talking about block structure. Block header. We have the following content in the block structure. That is, the header data contain metadata of the block, information about the block itself. That is the data which we cover, that is comes under the header data content. We also called as metadata of the block. We have following features when we talk about block structure, that is hash of a previous block header, hash of the current block, timestamp, cryptographic nonce, and Markley root. So when we talk about Markley tree, a Markley tree is a binary tree formed by hash pointer and named after its creator, called as Ralphie Markley. Ralph Markley. Okay. Um, as mentioned earlier, each block is supposed to hold a certain number of transactions. How the question rises, how to store this transaction within a block. One approach can be to form a hash pointer based linked list of transaction and store this complete linked list in a block. However, when we put this approach into perspective, it does not seem practical to store a huge list of hundreds of transactions, right? What if there is need to find whether a particular transaction belongs to a block? Then we will have to traverse the block one by one, and within each block traverse the linked list of transactions. This is a huge overhead and can reduce the efficiency of the blockchain. Now, this is where the Markley tree comes into the picture, right? Markley tree is a pre-block tree of all the transactions that are included in the block. What is pre? That is, Markley tree is a per block tree. That is, per block tree of all the transactions will have the records of each and every transaction block in block wise, like one to one. It allow us to have a that is hash digit of all the transaction provided to proof of membership in a time efficient manner. So, to recap, the blockchain is a hash based linked list of a block where each block consisting of or consists of a header and transaction. The transactions are arranged in a tree like fashion known as Markley tree. See here in the example diagram, block n1, block n plus 1. We have the header. What are the things we are having? The see here, hash of the previous block header, hash of the current block, timestamp, cryptographic nonce, and Markley root. See here we have the entire thing which we are working on. So let us talk about block n1, block n plus 1. So header, that is header, we have hash for block head n2, n1, n. Timestamp we have used nonce, we have used hash of the block n1, n minus 1, or Markley root. So here also, what are the transaction data which we have? That is h1, h2, like that it has been, the data has been divided. So similarly, each block composed, that is compression of block header plus Markley tree. So this is the way the entire transaction of data has been stored per, that is Markley tree is a per block tree of all the transaction. Okay, for this class this is sufficient, and we'll next class will continue with the next class. Thank you.